You only go on YouTube on here. How do I do it? Jay King View.
Yeah, they're really slow.
Are you?
I'm pretty sure my router.
Alright guys, I'm about to just go ahead and get started. Alright guys, so for all of those whose computers are booted up, go to this website. If not, look onto someone's computer who has this website up. Alright, so we're going to do an activity called Gravity in Orbit. Alright, so once you're here.
Pardon the interruption. Could I have June Choi to the main office, please?
Yes. Okay.
He'll be back in a few minutes. Thank you.
Bye, Jude. Bye, Jude.
Alright guys, so once you're on this website, Play with Sims, click here where it says Play with Sims.
Radiant.
Alright, now I want you guys to click on physics. Alright, click motion. Alright, now let's scroll down till we see gravity and orbit.
Gravity and what? Orbit.
Gravity and orbit.
Then do we hit download?
Just go to run now.
You hit download.
No, I hit run now. Nah, Bill. Download subscription.
Does anybody have this up yet?
Go. I know.
Here, play with
I got it.
I got it. Now what do we do, Mr. Curry?
The more times you sign the computer, the more
I got it, Mr. Curry. Now what? Exchange the size of the altitude and orbit.
it's loading hot to field.
Alright guys, listen up. I need everybody up here. Alright, so this program, it allows us to watch objects in orbit. Alright, now if you look here, we have the sun and the earth, which is going to be in orbit. In the top right hand of the screen, we have 4 different sets of objects. The first set of objects we have are the sun and the earth. The second set, which I can go to by clicking this button, gives us the sun, the earth, and the moon. Our third set of objects gives us just the earth and the moon, and our fourth gives us the earth and the satellite. Alright, so if you have yours loaded up, go back to the sun and the earth. And then you can hit this button. You can hit this button to watch the earth go around. How long does it take for the earth to go around the sun?
What, you think it's not gonna work?
Yeah, because I think I got the wrong.
At 365 days, it's going to be right where it originally
Yes.
started. Let's see if I can get it right.
Oh.
Okay, so,
Oh, I got mine up there, 67. Look at that.
alright guys, and with this diagram, we're analyzing the gravitational force, the period, and the speed of the objects that are in orbit. So if you look here, we have where it says we can show the gravity force vectors and the velocity vectors. So when we hit play, alright, we can see how the force of gravity between the two objects act on one another. And notice that the speed is always a straight line because it's referring to the tangential speed at any given point. I'm just going to pause it really quick. Alright, now, if you look here, there's a button that says gravity on and gravity off. So you can turn gravity on or off. Alright, now watch what happens when I turn the gravity off. Watch what happens.
Oh, it's not.
Yep, there we go.
Turn it on.
I'd say we have about half hour. Until we crash into
Will we
Mars.
explode?
Let's see if it
Will we explode?
Yeah, we probably just survive that long.
Alright, now notice that when I turned the gravity off, the Earth went into whatever direction its tangential velocity pointed in. So at this point, if I were to turn the gravity off, it would just go in this direction.
Is that true?
Alright, so I'll play it again so you guys can see. Now you notice it's going straight that way. Reset it. Alright, now, once we come to... Alright guys, so once we come down here, we have something that says star and planet. Notice that here I can change the size of the star by just moving this back and forth. Alright, and notice that there are 4 lines. Keep that in mind, there are 4 lines. We have line 1, which is here. We have line 2, which is says our sun, which is our default line.
Oh God.
We have line 3
My sun just my Earth just exploded.
and line 4.
Yeah, it's because you probably
Yes.
crashed. Just get reset off.
Alright guys, so when you do your trials, I want you guys to keep the gravitational force and the velocity, keep those vectors on there, so keep these boxes checked.
The path is where
Can you speed it up?
I want to speed it up.
This little play button that says, sim speed.
Alright, so guys, listen up. Here there are 4 lines, and we're going to use these 4 lines in our lab. Alright, so if you have your lab paper in front of you, I want you guys to read along with me. I'm about to read the directions, and this is pretty important. I need everybody to pay attention. So the directions say for each set of objects, we have 4 sets of objects. So for each set of objects, play the simulation at its default setting and watch what happens. Record your observations. Alright, so at its default setting, that's the setting that you get when you hit reset. That's its original setting, wherever it started off from. So I want you guys to, so for each try, I want you guys to play the simulation and watch what happens. You're going to record your data into your lab table. If you turn over to your second page, you guys are taking note of the gravitational force, the speed, and also the period. Alright, so next, what we're going to do, I need everybody up here. Alright, so next what we're going to do is change the size of the object being orbited, which is most likely the object in the middle of the screen that appears stationary, and watch how the object that is in orbit, which is this object, watch how this object behaves. So we're going to change the size of this object a total of 3 times. It starts off at the default setting, which is at line 2. We're going to move it to line 1, and watch what happens to this object's orbit.
Will it come back?
It will, but it's going to take like a very long time.
Those just pass.
Alright guys, just now, when I decrease the size of the sun, the earth just went like really far off. Now, why was that?
Because of less gravitational pull.
Yeah, there wasn't a large gravitational pull. Alright guys, so now I'm going to move my size to line 2. Alright, now watch what happens when the earth is larger. I want you guys to look at the objects of both speed and its gravitational pull.
That's
Alright, so I want you guys to record that in your notes as well. I mean, in your last sheet, sorry. And
Oh, we draw a picture.
alright, and for the last setting, when I have the sun at line 4, which is the top line, watch what happens to the earth. So this shows that when the sun is very large, that its gravitational pull will consume us. Now, I'm going to bring it back to line 3, and I want you guys to watch something. All right. When we had our sun at the default setting, which was at line 2, our period was 365 days. All right, so when we increase the size of the sun, now watch what happens to the period. I'm going to try to stop it when it gets to the right where it was. Alright, so our period when the sun is larger is about 193 days. Alright, so for each trial, you guys are going to take note of the gravitational force, the period, and also the speed of the object that is in orbit. Alright, and we have 4 different sets of objects that we're analyzing. Oh yeah, that's one thing I forgot to mention. For this lab, we aren't necessarily looking at numbers, because other than the period, there aren't many numbers to look at. Just write down exactly what you see. Just write down exactly what you see.
so you see it speed off your speed up.
Alright, so where there's a box on the right hand of your screen that says show, and for every trial, I want you guys to always show your gravitational force and velocity. And when you play your simulation, I want you guys to basically just record whatever you see. Record everything that you see. See for here, you see how our object sped up. You will write that down.
Are we working on this tomorrow?
Alright, so any questions? No, don't draw. Just write exactly what you see. Alright, if there aren't any questions, get started. Carefully read over the directions again. Work with somebody else.
Yeah, that's what you see it. And then you describe what you see, like just do the distance between the two arrows change at all during the orbit. Yeah. Yeah.
Yeah, I guess.
Yeah. So it's constantly. It's gravitational force. Oh, there we go.
You just right when you see.
But it goes right.
That's what, right?
Does it speed up at all, or does it get closer to it? Does it move farther away from it?
Thanks, Billy. You always been my best friend. So,
200.
it's not like.
Honestly,
It should take us a long time to do that, right?
Yeah, so for this, you don't have to wait that while back. I was back for a long time. You can just take the tree very long.
How many days it takes to get one?
And then here's how many days it comes back.
Yeah, good job.
Like we look around, like for some of these concepts with the orbit, like get close and speeds up.
Oh, serious.
Just basically write down whatever it is that you
on the 70th day, but the velocity remains constant.
You just look how fast.
Yep, doesn't speed doesn't slow down at all.
Gravitational force is right.
once you're done with your estimate, it's something
Smaller finger.
This,
Yep.
Did you notice that when you increase the sensor about right here,
Yeah. The second one was
can I put the period crashes to on
Yep. Oh, snap. See that? It's lit. I like it. Yeah. I was just gonna hit actually, to be honest. Chris. What? No, very high. It would come back to very low. So, but, it's very big. You left the apple.
Speed very slow.
Yeah. Bottom where it says play.
It's pretty strong. It's like a flag.
wasn't. It wasn't even happening.
Oh my. Oh, dude. Watch that. He crashed the bear. That was awesome.
That's a pretty good game.
I was not expecting I was not expecting to move the crap up here. I can guarantee that.
How many days do you think?
Line 3 and 4, you notice that there are
It's
4
one.
lines here.
First time, it's like 31 for the orbit year. It's like a month, it's like 28 days.
Is it? I don't know. Let me check here.
Second one might come.
Yeah, it's about 31 days.
Daddy,
The second one?
No, it's 1
The
day.
small ones? Doesn't come back.
30 minutes, sorry.
The smallest. The smallest.
Yeah, we can up and we'll
What's the little green line?
Crash on line
Wait,
four.
We'll do it in.
Yes, mine is correct.
So what did you put for the
Dude, it doesn't come
Alright guys, let's listen up really quick. Alright, so our blue arrows represent gravity. Alright, now notice what happens when we increase the size of the sun.
Dude, it doesn't come back.
Our blue arrows increase as well, which means that our gravity is increasing, so keep that in mind.
He said he told me it was that.
It does come back eventually.
After a long time.
Yeah, I'd say decades. We have a linear or something? I got 160.
Why'd you ask the black guy?
Did you reset it before choosing the outside?
Here, we can figure out this one like this.
Why are you talking to Josh like this?
It's about 27 days.
Smack. No. Wait.
Mr. Kirk. Yes. Does it look like to you that the earth is moving?
Oh, yeah, it is.
Yeah, it's moving in like a tiny circle. Is that because of the tilt?
It's because of like the moon also has an attraction force that pulls the earth.
Yeah, if it crashes, don't put a period, just put crash. Because it's not really a period.
I'm not sure if you like surf or not, but you know how like there's sometimes where when the moon is at like a certain position, they have like the right time.
Can I borrow this thing?
Everybody that's there.
Earth days on it. I think that's just Earth days.
Dang. Satellites travel around that. They travel around about 9 degrees.
Oh, and there goes the alright. Return object.
I'll be in July.
I just did Earth and Moon.
Yeah.
Do we keep going if the moon crashes?
Oh, you on Earth and then you report about the moon crash because it was had to be a lot.
No, she hasn't even tried right when it was.
Yeah, you have to talk about the moon too because it's on your thing.
The same.
What's the magic word?
There's two. Okay, that's not the magic word. What's the last one?
Wait, today?
Yep.
Oh, good.
Alright guys, for those who are on line one, don't wait for the whole period because it's going to take a very long time.
I'm gonna see how long.
Soldier school. Yeah.
Jack is very familiar character.
Yeah, I know. I want to be the boss. Like it says.
Oh wow.
Whoa, what?
About 31. It's like,
It's a month.
yeah, the month.
7 days.
No, it's 20.
Oh,
seven
the long
days.
one. Oh,
I had 30 bucks, so yeah,
I got 30. I
I
wouldn't be
was at
surprised.
28.
Really?
I got like 30.
Oh.
I got it at the Fedora.
I got it right. That's what I got.
Yeah.
27.
Yeah.
Oh, and there goes the satellite.
I would not be surprised if that actually happened. I could take him with my name, but I would not.
Snap.
Well, it only takes minutes.
Yeah, I'll just.
That's 90 minutes.
Look at that over there.
It took like 22 bucks.
I don't know. This is just Dora. I know.
It's like 22
What is it?
Yeah, that's why you moved. That was really pushing me.
Yo, it already crashed. Yeah, I told you. I pulled it through.
my God, I want
Mr. Curry, because the planet was so big, it already crashed, so can I put or none because it already crashed?
Yeah, you're right.
I'm done. Can we put on the computer?
No, you can't. Stay on that website.
Is it never?
There we go. I want to see exactly how long. Oh, Sean, this is where did I get? Of course.
Does it have anything about it?
Yeah, I'll take it for 40. I don't know what
Yes. What's your favorite game on here, Mr. Bob?
Oh, the pet simulations?
Yeah.
There's one on harmonics and sound waves.
Yeah, just move it out of it.
Yeah.
Just play it and then get it, just reset all and then move it back. So you go back to that, just pick, just do it again. That's it. No, not that, move the satellite.
Yes, so you look at the earth and the moon.
Everything's at different modes of vibration. And they vibrate at all those modes. They have like a guitar string, you pluck it, alright, maybe that's 440. But it also vibrates a little bit at 880 and 3 times. So on here, we can actually add in different wavelengths and multiple wavelengths.